As you know from your reading, factoring is the reverse of multiplication, and we want to start our work with factoring in this section by doing what's called factoring out the greatest common factor. Suppose I have 3a squared minus 21a plus 30. I look for the largest monomial that divides each term. In this case, I notice that 3 divides each term. If I factor it outside, what's left in the first term will be a squared. In the second term, what will be left will be 7a. And in the last term, what will be left will be 10. So I can always check to see that this is correct by multiplying it back out. 3 times a squared, 3a squared. 3 times negative 7a, negative 21a. And 3 times 10, 30. Now, as we proceed through this chapter, we'll see if there's any further factoring we can do on this trinomial. For right now, what we want to do, though, is simply factor out the greatest common factor. If I have 10x to the fourth y squared, 20x cubed y cubed, and 30x squared y to the fourth, the greatest common factor will have a 10 because 10 is the largest number that divides 10, 20, and 30. The largest expression I can find, or the expression with the largest exponent that divides x to the fourth, x cubed, and x squared, is x squared. And the highest power that divides highest power of y that divides y squared, y cubed, and y to the fourth is y squared. So I factor it outside. What's left in the first term when I factor out 10x squared y squared is x to the second. When I factor 10x squared y squared from 20 x cubed y cubed, what's left is 2xy. And when I factor 10x squared y squared from 30 x squared y to the fourth, what's left is 3y squared. Now later on we'll see again how to factor this trinomial that's left right here, but for right now what we want to do is factor out the greatest common factor, which is the largest monomial that divides each term in the trinomial we're factoring it from. Next thing we want to look at is called factoring by grouping. When we do factoring by grouping, we can't see in this polynomial right here any greatest common factor for all the terms. So what we do is we group the terms together 2 at a time and see if that helps. From these first 2 terms, I see that I have a 3y common. I'll factor that out from the first 2 terms, and what's left is x plus 1. I'll go to my second 2 terms, and what I have common to each of them is 2a. I'll factor 2a out. What's left here is x, and what's left here when I factor out 2a is 1. Now I notice I have 2 terms left, this term and this term, and each of them has x plus 1 common. So I'll factor it outside, and when I factor x plus 1 from this term, what's left is 3y, plus, when I factor x plus 1 from this term, what's left is 2a. So now I've factored my original polynomial here into the product of x plus 1 times 3y plus 2a. Here's another example. I can't find any greatest common factor for all 4 terms, so what I'll do is group them 2 at a time. From the first 2 terms, I can factor in x squared. When I factor x squared from this term, what's left is x. From this term, what's left is 2. Now, I go to the second 2 terms. I notice they're both negative, so what I'm going to do is factor out a negative 5 from each of them. What's left when I should say, how about negative 25? Because I can take 25 out of here and 25 out of here also. So 25 is the greatest common factor for these 2 terms. I'll take the negative sign with it so that this will be positive inside the parentheses. What's left when I factor negative 25 from negative 25x is x. When I factor negative 25 from negative 50, what's left is positive 2. Now I have left 2 terms. They each have in common factor x plus 2. I'll factor it outside. And what's left in the first term when I factor out x plus 2 is x squared. Minus, when I factor x plus 2 from the second term, what's left is 25. Now later on we'll see how to factor this x squared minus 25. For right now though, we just want to get some practice at doing this factoring by grouping.